GATE 2012 Civil Engineering question 35. Two plates are connected by fillet welds of size 10 mm and subjected to tension as shown in the sketch. The thickness of each plate is 12 mm. The yield stress and the ultimate tensile stress of steel are 250 MPa and 410 MPa respectively. The welding is done in the workshop, for which the safety factor is 1.25. As per the limit state method of IS 800-2007, the minimum length of each weld to transmit a force P equals 270 kN needs to be found, rounded off to the higher multiple of 5 mm. The four options given are A 100 mm, B 105 mm, C 110 mm, and D 115 mm. The relevant NPTEL reference has been listed. So when we talk about the design strength of a fillet weld, it is given by P equals the stress it can take into the area of the weld. So the stress value is given by the ultimate stress divided by root 3 gamma mw. Here Fu is ultimate stress and gamma mw is the safety factor. The area of the weld is given as the product of throat thickness and length of weld. The throat thickness is given by 0.707 times the size of the weld S. In this case, we have been given the value of P as 270 kilonewtons. So converting this to Newton, it would become 270 into 10 cube Newton. This P would be equal to the stress value the weld can take into the area of the weld. So stress is given by Fu by root 3 gamma mw. For this particular weld, the value of Fu is given as 410 megapascal and the safety factor gamma mw is given as 1.25. The size of the weld is mentioned as 10 millimeters. So using this, the throat thickness would become 0.7 times 10. So substituting all the values in the relation of P, we would get 270 into 10 cube, that is P equals the stress value, which is Fu by root 3 gamma mw. So that would become 410 by root 3 into 1.25 into area of the weld. So the area would be throat thickness, that is 0.707 into 10 into the length of the weld. So since it is a two-sided weld, let us assume the length on each side to be x. So the total length would become 2x. Using this, we would get the value of x as 100.83 millimeters. Since the question instructs to round off the answer to the higher multiple of 5 mm, we can round it off to 105 millimeters. That will be the length of weld on each side. So the minimum length of each weld to transmit a force P equals 270 kilonewton is 105 mm, that is option B. The relevant NPTEL reference has been listed.